Hello students, today we are going to start the lecture on transformation of substance. First we'll have a brief introduction about the topic, what does transformation of substance is and what does it include. So we'll be having some introduction about the chapter. Now we know that matter can be divided broadly into three categories. For substance you can say it can be any matter. So matter is broadly divided into It will be divided into solid, liquid, gas. These are the three states of matter in which matter can exist. So talking about solid, liquid and gas, we consider their states means how they are presently. Now why we have created this categories and what is the basic difference between them? We'll just have on the basis of some property the differences on them. Okay? For example, when I talk about first property, that is of shape. Now we talk about the shape of the matters, then solid has fixed shape. You see example of anything around you which is solid, it is having a fixed shape. For example, the pen, the table, the chair, all are having fixed shape and you can see they are solid. Liquid, they do not have fixed shape. Okay, they take the shape of the container. So we can say that liquids do not have fixed shape. Their shape varies with container. If I put some amount of water in a glass, the shape of the water will be of a glass, and now if I pour this water into a tumbler, it will take the shape of the tumbler. And if I transfer it to the jug, then it will take the shape of the jug. So we can see that it is changing its shape continuously. It is not having any fixed shape. It fixed Now fixed shape is that it does not change its shape whenever the container is changing. Here we are seeing that the liquid is changing its shape when we are changing the container. So we say that liquids do not have fixed shape. For gases also they do not have fixed shape. Gases also they do not have fixed shape, like you cannot say that the gas is of this shape or that shape. No, they do not have a particular shape. They also take the shape of the container. So here we can see on the property of the shape that solids have fixed shape, liquids and gases do not have fixed shape. Now the next property which we are going to discuss is the volume. For solids, we say that solids have fixed volume. Okay, they will be having fixed volume. When we can measure, means if I want to buy sugar, then I'll say 1 kg of sugar. Okay, so the volume is very fixed and it will be a particular amount only. Okay, for a piece of bread, we can say its dimensions are fixed and so its volume will also be fixed. But in the case of liquids, when I talk, they are having fixed volume. Suppose I talk about 100 ml of water, then the volume is fixed. But here again, it will change with the container and its shape will vary according to that. But they are having fixed volume. Okay. Suppose I take a glass and here I am taking a glass. Okay. Now here there is marking up to 100 ml and in this there is marking up to 100 ml. Now I fill water in this case. So it is occupying only that space where it is having the 100 ml mark. Okay, whether its shape is changing, but the mark is fixed and it is occupying only that much volume. Okay, but in the case of gas, what we see that the gases they occupy the volume of the container. Okay, that is you can say did not have a definite volume and they occupy the volume of the container. Now for example, in the case I can say if I am taking two different flasks, this is a conical flask I am taking and another one I am taking a round bottom flask. Now both of them are covered. Now this is having a capacity of 100 ml whereas this is having the capacity of 50 ml. The same amount of gas when it is put in this, it will have the volume 100 ml, and when it will be added in this, it will have the volume 15 ml. So we can say that they do not have fixed volume, their volume changes with the container. Okay. Now the next property we are going to discuss is the density. Density for solids is more. It is more in comparison to solids and sorry. It is more in comparison to liquid and gases. Okay. So solids are having more density than liquid and gases, whereas the liquid will have lesser density, than solids, and the gases, they will have the least density among the three. Okay, so we can say that, for example, I talk about H2O. Okay, H2O, if I say it to be ice, that it is in the solid form, and in the liquid form it is again water, then in the gas it's vapor. Okay, for here only the exception is this water which we are discussing, because the density of ice is less in this case and more in the case of water. Other all liquids, they are having more density and in the solid state and lesser in the liquid state. Okay, only the exception here we can talk about is because water, ice has lesser density. It is due to the bonding between the molecules. Due to this reason, there is difference in this property of the density. Other all liquids, we can say they are having less density, whereas the solids, they will be having more density. The next property what we are going to discuss is the intermolecular force. Can be called as interparticle force also, and it is also told to be intermolecular force. Now what does this mean actually, intermolecular force? It is the force between the two molecules. Okay, the force of attraction between the two molecules, that is the intermolecular force. In the case of solids, we see it is having high intermolecular force, or we can say it has to be strong intermolecular force. Okay, it is stronger in comparison to liquids and gases. For example, here if we want to understand the intermolecular force, what does it mean? Here I talk about two molecules of H2. Now this is one molecule of H2 and this is another molecule of. Now I'll take an example of water. So we can see in this case there is strong intermolecular force in the case of solids. Okay? Solids are having strong intermolecular force, means their molecules are arranged very close to each other, very compactly packed. Okay, and in the case of liquid, these molecules are less compactly packed. They are having some distance between the particles, and this distance is known as the intermolecular space, or we can say it as interparticle space. Okay. So we see that when the force is strong, then it will be solid, because we see they are strongly bonded to each other. There is less space between them. So in that case, we can say that there is a strong force of attraction between the molecule. There is strong intermolecular force. Okay, and in the case of liquids, this intermolecular force, it is lesser than solids, but is greater than gases. Okay, so the intermolecular force, it decreases in liquids than it is in solids. And in the case of gases, we see that the molecules, they are separated by good distance. The particles are separated from each other. We can see that the space between them has increased and the force has decreased. So we can say that there is least or minimum force of attraction between the particles. Now we talk about intermolecular or interparticle fluid, interparticle space. Okay. So the spaces in between these vacuums, you can see the spaces. These are said to be the interparticle space. Okay. Here the spaces, you can see the space has increased. In this case it is less and it is least in this case. So we can say in the case of solid there is least or negligible or very small interparticle space or intermolecular. Whereas in the case of liquids, the space is more than solids and lesser than liquid. Whereas in the case of gases, we can see the intermolecular space is greatest among the three, or you can say it is the highest among the. When I am talking about the transformation of substance, I mean that how do we transform the substance from one state to another. So there are different ways by which we can transfer the substance into one form to another. But before that we'll see the basic interconversion, what happens in them. Okay, and why does it happen, what are the various terms involved in those steps. So we'll be dealing with that. Okay, this was a brief introduction about just the states of matter and how can we distinguish between them, on what basis. Okay, so we can say that on the basis of these properties we can distinguish between the three states of matter, and these are the basic properties which we are going to deal with.